Good evening to our instructor, DS Hazley, and my fellow teammate. We are from Section 4, Group 3. Our group title was Automatic Watering System for Small Agriculture. Our team consists of 5 members, which are Bong Sinian, Muhammad Hafizan, Muhammad Noor Hasmi, Nawan Kumar, and Fritiyana. Let me start our presentation with the project description. Project description. The project is an automatic watering system that will using Arduino to automate the irrigation and watering of small-scale crops. This system does the control of soil moisture and doing the indication via LEDs, and in case of dry soil, emitting a beep sound from the buzzer. In case of dry soil, it will activate the water pump to pumping water from watering the plants. The system using the LCD display to notify all the action that taking place and a real-time clock. All the components will place in the circuit box for loop tying. Next was the problem statement. Agriculture is an activity that needs supervision from the human. It becomes a problem for people to monitor their crops' moisture level during their absence. In this project, the method that will be used is by using a moisture sensor to detect moisture level of the soil. Sensor will send the information to allow the watering occur. Project M. Developing a prototype of an automatic watering system that able to detect soil dryness using sensor and provide water to the plants. Water will be important element for all the life substance that the necessary to avoid it undergrid usage. Irrigation is a dominant consumer of water. This requires the need to regulate water supply for irrigation purpose. Water pumps get automatically off when system find enough moisture in the soil. The next part is objective. Our objective is to develop water management practice that optimize the quantity and the timing of water distribution. Water system shall turn on and off, so it will reduce the need for manual intervention. When little moisture in soil, irrigation will be activated to keep the plant from drying and increase their lifespan. The scope part I will pass to the next presenter. Thank you.
Okay, Assalamualaikum. I am Muhammad Noor Hasmi. Today I will present about our scope for the project that is automatic watering system for small scale agriculture. For our scope is to fulfill the state objective. The scope of this project is as the following. So, the first one is to reduce the manpower and time being used to operate the switch when it's needed. The second one is decrease the effort of trying to switch on and off frequently by the assistance of the sensor. The third one is to increase the lifespan of the plant and maintain the moisture of the soil by giving sensor without needed of regular checkup. Okay, for the next one, I will present about comparison of literature review. So for the first one is smart irrigation system using IoT and Raspberry Pi. So the advantage of this project is cost effective and provide feedback control system. And disadvantage of this project is one effect is considerable. The hardware is used is soil moisture sensor, temperature sensor, Raspberry Pi, and relay. So the software that will use is Raspbian OS or Raspberry Pi OS. So the technology is Raspberry Pi model. So the next one is automatic plant watering system. The advantage for this project is increasing productivity of crops, and the application are made through mobile. So the advantage of this project is increased maintenance that will cost a lot of money, and the hardware is used is Arduino Uno, master sensor, relay model, and water pump. So the software is used is Arduino IDE. So third one is automated expedient watering system for small plant and acquaintance about deficits in water supply. So the advantage of this system is only turns the water pump on when it's needed. So means that the water pump will on when the soil sensor detect the soil is dry. So it should instantly turn off when it's sufficient and detects any leakage. So the advantage of this project is expensive, and the hardware is used is light sensor, moisture sensor, single channel relay, Arduino Uno, LED, and relay port. Okay, I will continue to present the comparison of literature review. So the fourth one is automatic irrigation system using an Arduino Uno. And the fourth one is Arduino greenhouse control, humidity and temperature. And the sixth one is automatic soil moisture sensing, water irrigation system with water level indicator. So the advantage for the first one is implemented both garden and indoor plants, inversely proportional to the soil moisture. And the disadvantage for this project is poor conductivity and higher resistance. So the hardware is that used is Arduino moisture sensor, remove 5-volt relay module, 6-volt mini water pump with small pipe connecting wires, and 5-volt battery. So the software is used Arduino IDE. So the second one is for the advantage is safe energy conversion, real-time tracking, and the disadvantage is few second delay. And the hardware is used in light dependent sensor, temperature, humidity fan, fogger, and ripples. So the third one is for the advantage is simple and cheap, help to conveniently utilize their crops. Then the disadvantage is limited to be used for small garden only, sensitive to water condition, manual refill of the water. So the hardware is used is Arduino Uno, driver module, relay module, real-time clock module, hygrometer, water level sensor, and power supply. So the software is used also Arduino IDE. So I will continue to present the system block diagram. So first one we have Arduino. We have power supply, soil moisture sensor, water level sensor, LCD display, relay, motor driver, buzzer, button, and DC motor. So for the first one, the power supply will provide Arduino 5-volt, and the soil moisture sensor and water level sensor will connected to the Arduino, also the LCD, and also the motor driver. So the button is connected to the motor driver, and DC motor is connected to motor driver also. So LCD display will use a relay and a buzzer to when the project is dry, the red LED will on, and it will provide water to the soil. Okay, thank you. That's all for me. I will pass to the next presenter.
Assalamualaikum. I will present the system flowchart for our project. That is, we'll start with include LCD library code, and then it will initiate and declare the variable of LCD configuration, buzzer, relay, moisture sensor, water level sensor, LED, motor driver, and water pump. Next, it will set the sensor value as input and set the LCD, water pump, buzzer, motor, relay, and LED as output. Then it will set the LCD to begin with 16 to on serial begin 9600, and it will set the LCD cursor to 00, 01, and 02. On the LCD, I will print Arduino by myself on 00, watering system on 01, and welcome to 02. The next step is it will read the input from the water level. The water level sensor value, if it is more than 600, it will go to the moisture sensor, but if it's below 600, it will clear the LCD and set the cursor to 03 and print water tank is low. It will trigger the audio pin not G3 200 and turn on the buzzer. Next, we have to manually fill in the tank, and after the tank is full, it will go back to read the input from the water level sensor. But if the water level sensor value is more than 600, it will go to the moisture sensor level, and if it's more or equal to 700, the program will clear the LCD, set the cursor to 01, and print moist soil. It will trigger the moist soil LED pin and audio pin not C6100. The buzzer and LED green will on, and also the program will go to read the water level again. But if the moisture sensors scan is below 700, the program will clear the LCD, set the cursor to 01 and 02, and print dry soil on 01 and please wait on 02. It will trigger the dry soil LED pin and audio pin not C6100. The buzzer will be on and the LED red is on. Next, it will set the cursor to 03 and it will print water pump is on. After that, the relay will energize and motor driver will start the pump, and the relay is on, water pump is on. After all of that is done, we're looping to read the water level again. That is how our system flowchart is function. Thank you.
Good evening. My name is Navin Kumar. So my matrix number is CN200109. So today I would like to present about the 3D layout of my group project. Our project title is automatic watering system for small scale agriculture. So this is our 3D layout. This is basically the overview diagram of our project. So this is the box, which we keep all these components, all this stuff inside here. And this is the water pump which connect to the water tank, and the water tank is connected to a water level sensor, and a moisture sensor is connected to the plantation. Moisture sensor is over here. So yeah, so this is the idea of the 3D layout, and this is a side view. As you can see, this all these components, sorry, not all these components, this connection of each component will be inside this box. So the water tank and the plant will be outside this component box. This box is to keep all our components such as Arduino relay, motor driver, and all that stuff. So this is the top view of our 3D layout. So from top we can see that there's a connection, there's a pipe that will go through water from the water tank to the moisture sensor. When the sensor detect plantation is dry, means the soil is dry. So next I will present about the circuit diagram. As we can see, this is the circuit diagram for our project. So the LCD basically indicates the water level and the moisture level of the soil. And as you can see, this is the connection for moisture sensor. Moisture sensor is then connected to pin input pin, which then will trigger the relay to activate the buzzer. And when the water level sensor is low, um, the display will indicate the sensor is low, means the value. We should be able to read the value to know whether the sensor is low or not. And this relay will activate the water pump based on the reading that's given by the moisture sensor, because the relay is connected to the input pin from the Arduino. So when the moisture sensor is dry, it will trigger the relay to activate the motor pump to release water from the water tank. As you can see, from to water tank to the relay, sorry, to the plant. Okay, so next, I'm just going to briefly explain about hardware we used. So basically the main component is Arduino Mega and a battery to power up the motor pump, because the motor driver need additional power to pump the motor, and some battery holder to hold the battery, and a motor driver to control the motor, and an LED as an indicator for dry or wet soil, and a potentiometer to control the display of the brightness of the LCD, and a push button and an LCD to display the moisture and the water level, and following by a relay. In this project, the relay we used to connect to a buzzer, and a buzzer module which will be connected to the relay, and a moisture sensor and water level sensor is a very important component of our diagram. Okay, so next is the software we use to design to basically finish the project. So Microsoft Office, this we use to make report, edit report, thesis based on the format. And Arduino is basically what we program, and with Arduino we program and convert it to hex file. And with the Proteus software, we design the circuit diagram and use the hex file that is produced in the Arduino to be simulate in Proteus. And Google SketchUp is used to design the 3D layout of the project. So next, this is the project hardware picture. This is the when we complete the project. This is the top view, this is the LCD view, and this is the front view of our project. So that's all from my side. Thank you. So the next slide will be presented by my colleague. Thank you.
Assalamualaikum and hi, my name is Fitriana Adila binti Mat Saleh with matrix number of CN20093. I will continue on the next slide of conclusion All the objectives that were initially set for this project were successfully achieved, and the objectives are listed below. The automatic watering system are able to be controlled by using the Arduino with program code. It can water the plantation with the suitable amount of water according to the dryness of the soil, which using the moisture sensor to get the data. Thus, the objective of developing water management practice that optimize the quantity of water distribution is achieved. The automatic watering system can turn on and off with the aid of Arduino and several components like moisture sensor. The moisture sensor will get the data of dryness of the soil and send to Arduino to allow or disallow the activation of water pump to start operation. This will reduce the manual intervention. The objective for the watering system should turn on and off to reduce the need for manual intervention is achieved. For the recommendation and suggestion, firstly, we can improve the system by adding a timing system. For instance, every time the moisture sensor detects the soil is dry, the water pump will be activated continuously. Additionally, the main objective is to increase the lifespan of the plant. This will prevent overflow of water to the plant. We can improve the number of water pumps and increase the size of water tank to maintain a large pool of plant or soil. We also can improve the system by making it wirelessly. We can receive data wirelessly and trigger the water pump. The water level indicator also can be done wirelessly by adding a wireless module to the water level sensor. That's all from our group 3. Thank you very much.